Proposition 7, given two straight lines constructed from the ends of a straight line and meeting in a point, there cannot be constructed from the ends of the same straight line and on the same side of it two other straight lines meeting in another point and equal to the former two respectively, namely each equal to that from the same end. So that sounds pretty complicated, but the idea is pretty simple, and I definitely don't remember all of the wording for the proposition, but I definitely remember the diagram and what it's stating. So what this is saying is that, let's say you have one triangle here, okay, and then you have another triangle that also emanates from A and B, so like right here. Now it's saying that it's impossible for the sides to be equal that emanate from the same point. So it's impossible for CA to equal AD. Why am I marking them equal though? Because he proved this by proof by contradiction. So let's assume they are equal, right? And then let's also assume that this comes BD starts from B, and so does BC. So this equals that. Notice that it's referring to BC, not, if we call this H, it's not referring to BH. Okay, it's referring to the whole CB. Okay, so that's important to understand. It's important to understand. Okay. So yeah, and you want to connect CD. Okay, and let's see what happens according to our assumptions. Now let's just draw it a little better. So this triangle right here, according to our diagram, is isosceles. So that means we can mark this angle equal to this entire angle. Right? Simple, straightforward isosceles angle theorem, which we proved. Now, we can call it letters, but I'll just leave it like that. Now, this is also an isosceles, DCB. This is also an isosceles triangle. So, because of that, this whole angle equals this whole angle. And obviously, that's where our contradiction is. That makes no sense. I mean, just look at it for a second. The green angle is equal to this angle, okay? Now, this angle is less than the green, is equal to this angle. Basically, the less is equal to the greater, which is impossible. So that's where the contradiction is, The green equals the green. And then the pink would have to equal the pink. The lesser has to equal the greater. That's just impossible. So it's impossible for that to occur. So it's impossible for CA to equal AD. And it's impossible for CB to equal BD.